We are going. Hello, friends, and today we have a very special guest, Adelina the Dragon Slayer. So, initially I wanted to show you her profile on LinkedIn, and although her profile is really cool, I would rather let one person in. I would rather show her blog because I was quickly taking a look, and I really like this one. Like September 2021, I'm going to be a technology evangelist. And like today is 2022. It's not even 1 year, and she is a technology evangelist. Well, if I delivered as well on taking at least rubbish out or cleaning the kitchen, I would be I would be a much better person. So Adelina, it's all yours. I will stop sharing, and you can you can talk, and then well, what's your plan? Because guys, I don't know anything about this session.
Yeah, you can stop sharing.
Okay.
So I've prepared, because we were going with the whole like fairy tale kind of theme. So we're gonna live code the whole fairy tale, and we're gonna learn about Go. And
wow. So
I
cool.
haven't written, so just as a little bit of background, I'm Adelina, and I was a Java engineer. I started out as a Java engineer, and I've been writing Go since 2018. And I really like writing Go. In my Java days, I've taught a couple of people to write code from scratch. They didn't have technical background, so it's something that I really like to do. And I haven't, when it comes to Go, I've done some LinkedIn learning courses about Go. So I was really excited when Nikita invited me. And I think one of the cool things, it says you disable screen sharing. You have to enable it, Nikita.
Let me fight the first dragon. Yeah,
I can keep talking. Yeah, okay,
no, it's fine. That's me in technology. I'm very good in breaking things.
So one of the cool things that I think is nice when you see people write code is if they like walk you through the process of going from like a really simple version to a really like more polished version. So that's kind of what I want to showcase to you today, and we can learn all about Go. You can interrupt me with any questions that you want. I want it to be like a really informal, cool session. So I've prepared this repository called Gopherlina, and Adit is like my GitHub username. So if you look at the main branch, you'll see that there's like nothing here. You'll be like, oh, great, Adelina, you've prepared so much. Well, not, but I want to like go from the very beginning, from empty to like actual written code. So if you can't be bothered to watch me do this, then I've left a branch where you can see what we're going to arrive at all the way at the end. So you can just have a look at this branch if you'd rather just follow along for the written solution. So we're going to, these are the topics that we're going to discuss today. It's all written in the README. So I'm going to take you one by one. We're going to talk about variables and constants. We're going to talk about functions, modules, and packages, structs, interfaces, and if we have time, slices and loops. As I mentioned, I'm aiming between 30 to 45 minutes. So if you don't have time to stay, then you can just check out the finished branch. The way I see it is at the end, I will merge the solution back into main. And for the setup that I'm using is very, very simple. You shouldn't worry about it now, but I've left it here in case you want to emulate it later. So you just install Go for whatever operating system you have. It's got like a really nice installer. I'm using 119. And then I've got Go enabled in Visual Studio Code, and you can get the extension and get everything working. But if you don't have it now, then don't worry. We'll just watch and listen to like what I write and how it works, and then you can try it yourself later. So without further ado, let's get going. So does that sound good?
Yay.
Do we have lots of people with
That-
Go experience here, or?
Well, we have Dave Snowden, and he can do anything in world of, as long as robots are involved. Well, and or finance or robots or quantum physics maybe, but others might be not as knowledgeable. Guys, what if you tell us like what is your level of Go knowledge? Like just write a number in the chat, like from 0 to 10. 0 is 1 is Go exists, 2 hello world, and 10 I'm the author.
Stuart Murray is a friend of mine, so don't
Oh,
worry about him.
okay.
Okay, so we have some.
Oh, that's why I know your name, Stuart. Of course. Sorry, guys, I'm autistic, so like I'm extremely bad with names. And once I almost forgot my birthday. It was like 9 o'clock
Okay.
in the evening. Okay, cool.
Well,
Sorry.
I understood from Nikita that we don't have like a huge baseline of Go knowledge, so I'm just gonna start from the very beginning. So that's
Let's
why
start from the very beginning. So
yeah, I think
we can learn how to teach people and how to share Go, because a lot of people can code well in different languages, but not that many can actually explain you how to do stuff without sending it to MIT for 3 years. So yeah.
okay. So I'm going in general, we're gonna create Go files, like Go source code. It has the .go extension. So you can name it whatever you want, but by convention, main.go will have the entry point of your whatever application that you're writing. And it's required in Go. So while you can name the file whatever you want, main.go is convention, just to make it clear. You have to have it in package main. So if you have a command or an entry point for a program, then it has to live in package main, and it has to have a main method or a main function that takes no parameters and returns no values. So this is the signature of the main function in Go. Nice and simple. In Java, it's a little bit more complicated. It takes arguments, but this is the signature of the entry point of a program in Go. So usually when we want to print the console, we do so with a FMT package. So the FMT package is part of the standard library, and it exposes a print line method. So as I save this one, it gets imported automatically because I have the Go tools involved. So I'm gonna now do it, pass it a something to print to the console, sorry, to the terminal. Sorry, I'm a little bit tired. So we're gonna do our beginning line of our fairy tale. So in order for me not to like write it all the time, I'm going to put it on my other screen. I'm going to just copy paste what we're going to write, because you don't want to see me typing all of this all the time. So once upon a time, there was a little code base who lived in the village server. So that's what we're going to start with our fairy tale. So now if I save this, it's the same as what we would do for, hello world. So that's not very interesting, but it's a good place to start. So I'm trying to, how Zoom has this thing on the side where all the people, I'm trying to like move it so it doesn't cover my code. Okay, so in order to run this main program, I've moved the terminal here, just so it's like by itself without covering any of my code. Does anyone have a comment? Sorry. Yeah, so interrupt me, please. So the way you run a program is just go run, and then you say the program that you want to run, and we've named it go main.go. So if I do run, it says once upon a time there was a little code base who lived in the village server. So what we've just done, let me make it a little bit bigger perhaps. So what we've just done is basically like a nicer hello world with like a fairy tale skin, right? So that's not very interesting yet. So always in fairy tales, something goes wrong. I actually looked up like fairy tales Mad Libs, especially for this, which tells you like the how you should write, what the recipe for a fairy tale is. So then the code base is living happily ever after, for happily now. But then now something has to go wrong. So one day, unexpectedly, a ghastly monster darkened the village sky. So now we need to give a name to the monster. And because I don't want to continue just like writing random stuff in the terminal, I'm going to create a new variable. So if those of you who have some experience in Go, you already know that Go is a strongly typed language. So variables have a type. So I can either do it with var name, so that's the name of the variable, and then give it a type, but that's not very nice. Oh, and also it's underlined because variables need to be declared and used in Go. So now it's saying that I've declared this variable and not used it anymore. But it's much nicer to use the shorthand. So the shorthand is with the colon equals operator. So name colon equals, and then we can call it, then give it the value that it's supposed to have, and the compiler will infer the string type. Please interrupt me if I don't want to go too much into like types and stuff like that, because that's not very interesting.
It's just so beautiful. I'm really enjoying it. It's like I wish I had teachers like that before it all got messed up.
So the name, this is going to be the name of our monster. And the name of our monster is the new requirements dragon. So this is the new requirements dragon, is the one that's going to appear in the village sky. And the requirements dragon will say, so we've got a name, and then it'll be like the message that he's going to say, or like how he's going to threaten the village, the code base. And he's going to say, this is my home now. You must all go live in the clouds before sundown. So the little code base is living in the village server, but it has to go to the cloud. So now I'd like to introduce a new thing. We've seen how to use the print line. So I would like to introduce a function. So main is just a function that is declared with the func keyword. That's how we declare functions. And then the name of it is main, and this is its signature, right? So it takes no variables, and it takes no parameters, and returns no, it has no return value. So I'm going to declare a new method, a new function, sorry. It's going to be func, and then it's going to be called roar, because the monster is going to roar. So I'm going to take in the name of the monster, which is of type string. As we remember, it has types. Go has types. And then we're going to take in the message, which is also of type string. And then we're going to make the monster roar. So what you can do in Go to make it even more, to make it simpler, is if the parameters are of the same type, then I can just omit the type and put it like this. So then the compiler knows that both name and message are of the same type, and that is the type string. So this makes it sometimes nicer. So yes, please interrupt me as well.
Yeah,
so
why is the name and message, why there's a red on line 6 and 7?
This is what I said. They're so far they're unused. So
that's right.
yeah, in Go they must be declared. So like it has to be valid. So for example, if I don't put the colon, then it'll say that it's an undeclared name. The colon says this is a new variable and this is its value. So now you can see that it's declared but not used. So this is a Go specific thing where everything has to be used. But don't worry, that's going to be fixed very soon when we make the monster roar.
I like this thing. Everything has to be used. Well,
Yeah.
sounds like a good project manager.
Yeah, so it has to be, this is they did it like this in Go to kind of like eliminate bugs and unused code, because you might have like variables shadowing each other, or you might like forget a different value. So they've like enforced it in Go. So I'm going to show you, we're going to just work with like printing stuff to the console, but I'm going to show you to the terminal. I keep saying console. I don't know what's wrong with me. But so we're going to keep using the FMT package. We're not going to do anything fancy with other packages. But what you can do is FMT, and then I showed you print line, which just prints a line. So printf stands for print and format. So you see it takes in a format and then values, and then it prints those to the terminal. And usually this is a very important, it has to take these parameters. So that's why it's like right now underlined in red. So we have to say, here I'll give it the format. So we say the monster is going to go raw. I don't actually know what sound dragons make. So, you know, it's just going to be raw. Yeah, so you can say here, I'm the, and then you can do a %s, which says this is the parameter that's going to be supplied, \n, which says new line. And then we can pass it the name of the monster that's roaring. So what's happening now is this %s says that it's a parameter of type string that's going to go there in the format. And then wherever the %s is, that's where name is going to be inserted. So if I put %s here, then it gets put in there. And this is just a nice way that we can parameterize the strings that are going to the terminal. And then it's going to just say print line. It's just going to roar its name and then the message that it's carrying. So it's going to tell you that like you must all live in the clouds before sundown. So now it's time to invoke. This function will just live there by itself unless I invoke it in the main, because that's where the entry point of the application is, right? So I'm going to now invoke roar, and I'm going to pass it the name and the message that the monster is carrying. And as you can see now, there's no more red underlines because we're using all the variables that we've declared. So I'm going to just run it one more time so we can see what is going on. So this is where you see that the whole fairy tale has come together. So the new requirements dragon enters and tells the little code base that it has to leave its home. Okay, then we need to insert, so the little code base is obviously scared because like, oh my gosh, I have to leave my home. So I'm gonna say that. Sorry, I need to put the you need to put the quotes, or the quotes around the text show that it's one string. And then you can say, so that's why I have to keep putting the quotes around it. And in print line, you cannot have you cannot have new lines inside it. So that's why it goes red until I remove the new line. It's just because I'm copy pasting from my notes where then there's a new line at the end of it. So the little code base trembled. Is there a hero out there that can help us? So it's time to create a hero that can come and save the day. And we've already seen functions that take in parameters, but I don't want to continue just writing code here in the main file because that's uncool. And we all know that having like really long source files is really cumbersome to read and to see like where stuff is happening. So I need to now start to break up things and put them in other folders or other files. And the way that works in Go is with packages and modules. So a module is we can think of the module as the entire code base here, which is the a module is a collection of packages that need to be built and released together, while a package is a collection of source files that need to be built together. So you can think of a module as containing a whole bunch of packages and packages containing a whole bunch of source files. And this gives us fine-grained control of how we bundle the code together. Does this make? I'll show you how it works in practice, and then you'll get more of an idea. So the way we declare a module in Go is with a Go mod file. But I don't want to write one because I'm really lazy. So we have the Go mod. So the Go, when I write Go, this is the Go toolchain, which contains all the Go tools that you're able to use in your code. And right now you've seen Go run, which builds and runs the code that I've written in main.go. But now I'm going to introduce a new, which is the Go mod, which stands for Go modules. And then you pass an init command. And it says Go modules initialize. And then after that, let me actually press like this, and you can see it doesn't know what the module path is. So you need to tell it what should the name of your module be. So I'm going to do it again, and then by convention, so the name of a module should tell the people should tell the Go toolchain where to find the code and what its purpose is. And in general, we use the name of, it's good practice to use the name of the repository. So that's what I'm going to do now. You don't have to do https://github.com because the Go toolchain has GitHub mapped in its functionality and is able to know, like if I put github.com, where to go and fetch it. So I'm going to call it github.com edits, and then it's Gophertail, which is the name of the repository that I created. So it's created it, and it's once you have a module, you can also import external code from like other repositories and other libraries. Now, if I go here, you see that the Go mod file has been created successfully by my Go mod init. So now I can make a collection of packages that the compiler will know to build and use together. So by convention, if I were to create a new, okay, let me just do it here. So I'm going to create a new file here, which is going to be called hero.go. Because that's what I'm looking for, someone to save the code base, right? Anyways, so if I call it here package hero, then we're going to see that it complains. And then it says like that package hero and main are in the same directory. So with two notable exceptions, which are internal packages, which I won't go through here, and test packages, Go only one single package can live in one directory in Go. And this is again rooted in the way that like Go organizes code for simplicity. So you don't want like a whole bunch of packages and a whole bunch of stuff to be in one place, because that's messy. So I'm going to now create a new directory, and then it's going to be called hero. Or, you know, we can call it good guys if you want me to. I'm just going to call it hero. And then I'm going to move my my new file there. And then what we see here is that it's now fine. So the compiler can see that I'm in a new directory. So now I can declare a new package. So we've seen, so far we've worked with the string type, which is just a primitive in Go. Let me just move this up here. It's better. Sorry. Which is just a primitive in Go. But I'm gonna now teach you how to make your custom types. So there's no classes in Go. There's just these things called structs, which are simply a way to make custom types. So the way I declare it is with two simple keywords. So you go type, and then you call it the name of it. So I'm going to call it a gopher, because, you know, the gopher is going to be the hero, because that's the whole point of this. Anyways, And then you call and you use the struct keywords. So then inside here, now I've declared a new type. And you see how I've capitalized it. So the capitalization in Go, there's no visibility modifiers in Go. There's just exporting. And the way you exporting something means that it's available outside of the package that it's defined in. And I want to export the Gopher because I want it to be available in the main package where all the main stuff is happening. So this means that it's only got local visibility, and then the compiler says that it's unused because it knows that it's unused because nobody is calling it inside of its package. So I'm going to export it because I already know the Gopher is going to do stuff in the main package. Does that make sense? Yeah.
This is beautiful. So it's not so capital letter means it can be accessed out from outside the package, right?
Yes.
And there can be only one public class in the package, or
you can have as many. So there you can have as many source files and as many structs in one package as you want.
Okay.
But it just can't be multiple packages in the same directory.
Cannot be multiple. Okay. And
so I can't do like hero2 in another file in this directory. It all has to belong to package hero.
Oh, so you can have another file, but it still has to belong to package hero.
Exactly, yeah.
Wow, this is so different from other languages.
There's no like public, private, there's none of that. It's just exported or unexported. And then the packages have to be the same in the same directory. I will demonstrate once more. I only have one hero, but I'm going to have, spoiler alert, multiple monsters. So then we'll be able to see how that works.
And the question, doesn't correctly, you're actually using ID which is built into GitHub, so you literally press dot and you code right there?
No, so this is VSCode.
Oh,
so it's local installed here on my machine. I prefer VSCode because like you can use GoLang as well, but so you can use GoLang as well, but I prefer VSCode because it's free.
But in
GoLang
GitHub
requires a license.
But if you press just a dot on your keyboard in GitHub, it will open basically same screen in the browser.
Really?
Yeah, let's try now. If you don't like, I didn't know that as well. Yeah, so just press a dot. Yeah, it was the same reaction from me. It was like, what?
Get out.
Yeah, so you can code from your phone or something. I don't know. I can try it from phone, but
I think this is called code spaces. I think it's called GitHub code spaces.
Let's not use this one for this presentation too much because I haven't tested it. I don't want to mess up the story, but this is good.
Yeah, I'm just gonna go back. Yeah, but I've installed it locally, and also like it allows me to mess around with the terminal. I think it's all running in Docker over in code spaces. Yeah, can you show it again? I'll show you again. Does it not work on your side? I think, yeah, so I click dot. So I think if you fork it,
yeah, so guys, spoiler alert, I think Adelina inspired me to bring Benjamin Muscala from GitLabs. So as long as like I can bring them together in the same space, that will be so cool. Because he taught me all the stuff. He was like, oh wait, there's more. So yeah.
Okay, I'm gonna go back because I feel like we've already gone 30 minutes and I don't want to keep people too long.
We can always have one more session. So, but yeah, there are no rules. You set them. Like whatever you say is the rule.
Okay, well, maybe if we run out of time, you can just see the rest in the like finished solution. Okay, so here inside the custom type, you can name fields inside it. So I can give the Gopher a name, and that's all I want to do. So this allows us to instantiate an instance of struct and then pass it the name. Types can also have functions attached to them, and then they become methods. So the way that you may go from a method, so for example, if I have enter, which is like just saying enter for the Gopher. Sorry?
One second, somebody new joined and he didn't put his now it's muted. Yeah, cool. So sometimes people don't mute mix, but now it's all safe.
Oh, sorry, I thought you had a question. Go for it. Yeah. So this will just be a function if I leave it like this. It's not attached to the Gopher struct or anything. But the way that you do it is you give it a method receiver. So the method receiver goes in what you call these round brackets. And then you give it the name. So usually we go for very short names in Go. And then a type, so a G Gopher. And now what happens is this is the implicit first parameter of the enter function, which means that anything that's defined on this, I have access to in the enter function, and I don't need to pass it like this. So you don't need to pass it as a parameter. But also this function can now only be invoked if you have a created Gopher instance. So I'm gonna copy paste some more stuff because I don't want to write everything from scratch. So we're gonna print F the name of the hero. So the name of the hero is going to be Super Gopherlina. Because my name is Adelina, so that's where the joke comes. But I'm gonna remove this as being hard coded. So I'm gonna do a %s as we saw before, which is like the type of what we're gonna pass. And then the \n says end with a new line. And then I'm going to pass it the name of the Gopher instead. So then we can give this Gopher a name, and then they can enter and say what's going on. And then I'm going to write one more line because, you know, in fairy tales, heroes have a very like grand entrance. So they're going to say, so what happens now is that strings are the strings are defined by quotes, and I've defined some quotes inside here. So the compiler thinks that the beginning, this is the beginning quote and that's the end quote. So you need to escape it with a \. So as an escape character means that we're telling the compiler, this is not a special character, just use it as it is. And we escape stuff with the \. So then I'm going to escape this one as well. And then it knows that this is the beginning quote and that's the end quote, while these ones are in the are just like in the message and they're not special quotes. I hope that makes sense. So the hero enters. And then I can define as many functions as I want here. So I'm going to define one more function or one more method with the exact same signature. So G Gopher, so it belongs to the Gopher or a hero. And then this is going to be a save method. And again, why is it capitalized? Because I want to have access to it in the main package. If I leave it like this, then it's only available here and the compiler knows that it's unused inside the package. But if you export it, then you could use it other places and the compiler won't be able to say that it's unused. So then the save is just going to be another print. Sorry, this one, print F. And then we're going to say that the hero took it away from all the monsters and the saved it. So again, I'm going to remove the %s. I'm going to remove the actual name and use the name of the hero. So let's go back and see how we can use what we've written here. So what we have here is a Gopher struct that defines that is exported itself, and its name is exported. Exported means that I can set this outside of the package. If I want something to not be set outside of the package, then I don't use the capital letter. I can have something here which is called name2. So while the Gopher itself will be available outside of the package, name2 will only be available inside of the package. So you can have this mix and match of what you want available outside of your package and inside of the package, kind of building it like a small API. These are more advanced things that I don't want to cover right now, but I'm just planting you a little bit of a seed of what you can think about later if you wanted to like continue
And
right.
yeah, for example, I have a question, like, so it's a very simple one, but if I wanted to learn more about what is string in GoLang, can I just control click on it, or like, is there some?
Yes.
Oh, okay, I see. Good, thank you, because I love reading this stuff.
Yeah, because Go is open source in the way they bundle dependencies together. It's all like here on my machine, so you can click on anything. And if you were to take my code and then import it in another package, and because it is public, you can open it up and then see all of the code that I have written as well. Okay, so I'm going to go to main. And then we'll be able to, so first, there's no, as I said, structs are just custom types that bundle fields and methods and for functions or methods together. They're not actual objects. So there's no new method. You didn't see me make a new method. So the way you create an instance of it is you create a G, for example, and then we use which is the name of what I'm going to call my variable. Then we use the colon equals exactly like we had with the strings that we were using. And then I need to say what the type of it is. And this is where the module will kind of like get to come into play. So I can't put Gopher here because it's not defined in this package. It'll be like, I don't know what you're talking about. It's not in here. You need to qualify where it's from with the name of its package. So you see that the package is defined here. So I know I need to go hero.gopher, and that'll tell the compiler, look in another package because I don't have it here. So I'm going to do hero.gopher. And then what you see here is the tooling, or like the Go code tooling, has imported the package up here. And this is something that's really interesting because what you see here is the name of the module. You remember I called it added Gopher tail. And then we have the name of the directory that this is called. So it doesn't matter if I'm importing packages that I've defined or someone else has defined, they are qualified with the entire module name.
So you can import packages from GitHub like that?
Yeah,
or?
from other repositories, yeah.
So not only GitHub even?
So it has support. We can look it up later. It has support for GitHub, Bitbucket, Launchpad, but you can also make changes to the Go tooling with like vanity, with other kind of mappings. And then you can support other source repositories. But this is called, I've named it github.com because most of the code that we use is on GitHub. I mean, let's be serious.
Now I know why Java developers are switching to Go. Like really, after spent half a day trying to get a repo, some dependency in, and then somebody, Adelina solves it in 5 seconds. It's like, all right, Gradle, you know what?
Yeah, but what I was saying is, like, for example, in Java, internal packages are treated, so packages that I've defined in my project are treated differently than imported packages. Well, here it's the same because it qualifies the whole package with the module name and where to find it. So and then here, what you can see here is you'll be able to see the definitions. So now that I've imported, you can see the documentation. I should probably write more docs, but you know what, we're running short on time. So what you can see here is the name of the string that you can give it. So when you do, you can give a name by just giving it the, just qualifying the name of the field, and then giving it the value that you want. So we wanted super Gopherlina because that's me. And then you see here that it ends in a colon because I could have other fields defined. If I put it all on one line, then the colon gets removed. And this is perfectly valid. But in general, we define the fields each on their own line and end it with a comma. So now I've created the Gopher, but I need to tell it to do stuff, right? So the way I do that is with the name of the variable G, and then they can enter the scene and then save the day. So then that's kind of like how you do it. And then actually the fairy tale ends because the hero saves us, right?
Thank you, super Gopherlina.
You're welcome.
So from now on, for me, you're super Gopherlina.
Because my name is
let's try to change your passport. That would be so good.
You can only define, so you can only have one Go mod file. Sorry, I'm responding to a question in the chat, which says, should an application be only one module or can it have multiple ones? You can only define one single Go mod file in the root of the repository, so you can only have one module. And this is again to keep things short and simple in Go.
Adelina, I didn't ask how much time do you have? That's really
I don't want to keep people for too long because it can be a bit annoying.
So I left a link to your Twitter account.
Okay,
so and also I left a link to I'll post it again to my post. So you can either retweet what I've written, or you can just post a tweet mentioning Adelina's name and ask a question there, and
yeah, anytime. Yeah.
Somebody will come for help. And well, she has many powerful friends.
You don't even know the power of my friends. No, I'm joking.
Oh yeah.
Okay, so I'm gonna now just quickly run it to show you that it's working. So I forgot a /n here. So like there's one line that's the same. So the whole thing is working. We've put together two packages that are the same. We've put together two packages. One is called hero and one is called main. Under the hood, the Go compiler has put them together and created and built them, and then is able to run them. Now, if people are keen, I can demonstrate one more. Let me just fix my new lines. I can demonstrate one more example. If people wanted to, I can demonstrate the power of interfaces. But if you'd rather, I know it's 45 minutes. If you
that's fine. We don't hold anybody, but I guess well, I mean, we all appreciate it if you guys stay, but life is life. I know life happens. So if you can give us just a little bit more answer, and maybe then more time, and maybe then we can ask questions.
Yeah, for
although
sure.
I'm so like overwhelmed with all the stuff. I'm like, well, I need to have a curry and think because this is so cool.
Okay, well, I will show you the power of interfaces. So, you know, we've seen here the roar that takes a name and a message. So that's not very nice. I want to make the monster kind of behave in the same way as the gopher. So I'm going to create a new type that, because, you know, it's much nicer to pass it the name and then it does whatever it wants inside. So you don't have to like constantly pass these things as parameters. So I want to now create a new package and which is gonna have a monster inside it. So we already know that I can't create the different packages in the same directory. I'm just going to speed up a little bit because this part is the same as what we've seen. So I'm going to create a monster. I'm going to put a file in this directory, which is going to be called Dragon, because we know it's the new requirements Dragon. And we always need to give the package. The package doesn't need to be the same as the directory, but you would be committing a faux pas if you did different ones. So it just always use the same name as the directory. So then I'm going to type, I'm going to call it a type Dragon, which is going to be called, which is going to have a struct as well, which is just custom type like we've seen. And then this has a name. And then we saw that it has a message, so something that it roars. So then I'm going to go back to main, and then I'm going to cut this method out, this function out, and make it a method for the Dragon type. So how do we convert a function to a method? We give it the receiver. Sorry, I think okay. We give it the receiver. So I'm going to call it D for Dragon. And then I'm going to export this method called roar. And then all of these things can now be removed. So I'm just showing you the refactoring process. I don't need, oh, sorry. First, I need to save it so that FMT can be imported. So I don't need to pass these things in anymore because I can implicitly find them from the method receiver. We remember that it is the implicit first parameter of the function. So now I can just say d.name. So I've simplified things a lot because I don't need to pass them in now. And then d.message. Cool. So now I'm going to go back and refactor here so that I can create the monster. So I'm going to call it a Dragon. So I'm going to go monster.dragon, and we can already see that it imports the monster now. Here we go. And then its name is, I'm going to pass the name variable that I had at the top so I don't have to rewrite it. And then what was I doing? And then message, which is what it roars. So I'm going to pass message. But now I no longer invoke it like this, right? I need to invoke it with the actual struct that I've created, with the instance I've created. So I'm going to call it d.roar, and then it takes no parameters. So then now I've got my own Dragon type. But I want to do another thing, because when things happen, they go bad really very quickly, right? So I'm going to create a new monster. So this monster is going to be called a witch, because I was feeling fancy. So this is where you see where it's exactly the question that you asked me earlier, Nikita. So I can have a new source file that has the same package, and then I'm going to call it a type, and then the witch is also struct. And then it also takes a name and a message. So exactly like we saw earlier when I put one type, I can also do a name message here. And it will infer that both of them are type strings to make things shorter. There's different opinions in the Go community whether it should be like named, whether it should be explicitly named on each line or not. I'm just, I kind of feel like if it's very simple, then this is fine. But if you have a large array of fields, then it can become more problematic. So the witch, I'm just speeding up now a little bit just because I really want to show you interfaces. So the witch is exactly the same as the dragon, and we're already starting to see some things like, oh my gosh, maybe they have more in common than we thought. So the witch is going to curse us. And the witch is going to have a name and a message. Let me actually copy paste from the dragon. So you can see, so we can have a little bit easier time. So she's not going to say raw. She's going to say heckle, heckle, because again, I don't know what which is saying. And she's going to tell her, name, and then she's going to deliver her curse message. I meant heckle, heckle. Okay. Then now I've got two monsters that can appear, and I'm going to go over here in main, and then I can create the witch as well. So I'm going to create the witch after the monster, the first monster's roar. So I'm going to call her a monster dot witch, and her name is, she is the high latency witch. Do you know, do people know what a latency is? So basically, latency is in general defined, and people can correct me, like once you issue an instruction, latency is how long until you get a response from it. And in traffic, and when on the web, when you talk about request latency, is how long from when I tell you to fetch me something until you respond with that said thing. So if you have high latency on your website, then it's like a slow moving, slow responding website. So that's what she's going to curse us with. And she's going to curse us with high latency on all our web traffic. So that is her message. And then we need to invoke her method. So she curses us and then continues on. But we already saw that they have stuff in common, right? These two. The dragon has a name and a message, and then it does something. And then the witch has a name and a message, and then she does something. So this is where it would be nice if we could define some kind of general behavior. And Go doesn't have inheritance. So I can't define a superclass and then like implement it and do other stuff with it. But I have one really important thing, and it's called an interface. So an interface is just defined with in a similar way to the struct. So I'm going to define it outside of main here. So it's going to be type, and it's going to be called a baddie because they're like bad people. And then has the type interface. And that's all it needs to have. So an interface is a collection of functions or methods. And you can't create it. It's equivalent to an abstract type. You can't create it yourself, but you can use it to encapsulate the same behavior in the same kind of struct. So the baddie is going to do bad stuff. And then it's not going to take any parameters. It's not going to return anything. And the way that it works in Go, there's no implements keyword, there's nothing like that, is the compiler simply, if you have the same signature of this method that's defined here, then the compiler will know that you are implementing this interface, you're compliant to this interface, and then it'll be able to cast your instance immediately. So I can create a kind of like slice of bodies. So a slice is a dynamic array. I think now maybe I've introduced too many things, but I'm just going to show you how to declare one. So we do it exactly the same. It's really easy. So we can do a bodies slice, and we do it with the square brackets, and then we'll call it a baddie. And then this is how we have an empty slice of type baddie. And this kind of slice, it's just a dynamic array. There's nothing else special about it. It exposes no methods, but we can access stuff by index on it. But if I were to take my dragon, so let me just take this down under the definitions of everything. So if I were to take my dragon and try to save it in the baddies slice, then something bad happens. It says I can't use it because it doesn't implement the body interface. And then it tells you exactly that you're missing this method called do bad stuff. So this again, you know, the compiler already tells you the only thing you need to do is you need to go back there and you need to implement this method. So I'm going to go back to the dragon and I can say, okay, so if I go func and I do bad stuff and I go back to main, then we see that, oh, it still says that it's not implementing it, but I just defined it because it needs to be it needs to have its receiver. So it needs to be attached as a method to this type. So we remember about defining the function receiver and turning it into a method. So I'm going to call it the dragon again and then save this. And if I go back to main now, it says, oh yeah, never mind, it's fixed. Because I've now attached this function that we defined up here, do bad stuff, to the actual dragon type. And a cool thing that it can do now is I can say d dot. So the bad stuff that it does, our dragon just roars. But if we now think about it, do I want to expose roar outside of my package? Because now I can just say do bad stuff, and then maybe the dragon evolves and it wants to start doing other bad stuff. So what I'm going to do now is I'm going to unexport the roar method and then call it roar here. So it's still available here inside the package, but in main, I can no longer call it explicitly because now it's been unexported, right? So the only thing that we see now is our defined interface, which is do bad stuff. So I've now got a mechanism of putting some stuff away in my package that is only internal inside my package and expose whatever I want outside of it. And you might be wondering, why did I define the baddie type here instead of in the monster package? This is the way that it works in Go, because I can actually define as many interfaces as I want. And if I want to, and I can satisfy them all as long as I have the implementation of their defined methods. So I'm going to go back. I'm going to make the witch do bad stuff as well in the same way that we did it with the dragon, because obviously the witch is also a baddie. So she's going, we need the witch type to be attached to it. And then she doesn't, I'm going to unexport her curse method. So now she just looks like any other baddie. It doesn't matter what she decides to do. So then inside the method, she curses, but maybe she wants to like throw spells later. You know, you never know. They're always changing and getting worse and worse. So when I go back to the method, then she also does bad stuff. So now I'm going to remove this as well. So the way that it works is this is defined underneath the baddies. So I don't have access to it to put her inside the baddies and the baddie slice. So I'm going to move her definition above. And now I have two people that do bad stuff inside the baddie slice. And one last thing that's really bothering me, right, is the fact that I'm now calling, I've got this interface that's cool, you know, it's allowed me to define the do bad stuff on both of my monsters. But now I'm calling them, you know, one after the other, and it's the same invocation and makes it look kind of messy. What if I decide tomorrow to make another baddie, like another monster? Well, I'll just have to come and write this like maybe 15, 20 times. So this is where a for loop becomes useful. This is the last thing I'm showing you, I promise. So you can write an old-fashioned for loop up from I to len, but I don't want to do that because everybody knows how to do it. So I'm going to show you the range, the for range. So I'm going to do for, and then the range operator returns an index. So I can say I, and then whichever the the element that that index is. And then I call range and then pass it the slice. So then I've got an index here and a B for the body. So I can now say inside here, I can say it doesn't matter who the body is. I want you to do bad stuff. So the type of B is actually baddie, not like witch or dragon, because we know that it's like under the hood, they've been cast as this interface type, and it doesn't matter what they actually are. So I'm going to remove this one. And then I can print the index or I can disregard it. And the way you disregard something, because again, I'm not allowed to have stuff dangling about that I don't use. And though sometimes I don't want to use whatever everything that a function returns. And the way I ignore that is with the blank identifier, which is just the underscore. And that's the end. That's everything I plan to show you. Let's just run the code one more time because, you know, it's our pride and joy now. So that's the fairy tale that I've told you. First, the little code base lives in the village server. Then the new requirements dragon appears. The high latency witch out of nowhere now wants to come over and curse us as well. And then Super Gopherlina appears, helps us, takes away the database up in the clouds, because, you know, so the reason that I did up in the clouds is because one of the main usages of Go is to build cloud native applications, and everything ends happily ever after. So as I mentioned in the beginning, I'm just going to re-mention it for people that came afterwards. So the main branch is empty right now, and everything that I've written for you live right now is in the written fairy tale branch. I will merge it back into main after this, and then you can see everything here. One last thing that I feel like you are going to ask me about already, so I've prepared some answers, is contributing to OSS with Go. So I looked this up a little bit, and then I put Kubernetes, the OpenTelemetry project. So once you open these links, they're like how to get started and with contributing in all these projects. But then I found this super cool website, which is called Up for Grabs. I don't know if you know it, Nikita, already.
No,
So
first time I see it.
It can filter with Go, and I think we can click good first issue as well. I don't know exactly how to, oh, here, good first issue. And then you can kind of like see projects that are using it. So for example, Kubernetes has 19 good first issues. I don't know exactly how to use this website, but like I think it's working. So if I remove this,
Yeah, I'll find out, guys. I will create a video on that. Oh, Adelina, I'm not taking the. I will definitely mention you.
Don't worry. So I've left it here for you to see. And that's all I've got for you today. Thank you so much for staying with me. And I hope you found it useful.
A round of applause. This is so good. The only close experience, like from emotion point of view, that's listening to Venkat Subramaniam. So that's and well, so now there are two of them. This was amazing.
I have this plan if people are interested. So I've now shown you like the power of interfaces in a little bit. If you wanted, we could do a second video where we make the fairy tale concurrent. So one of the fields that is kind of like what I like to do is I've written this course about Go concurrency, where we can look at Go routines and channels, and I can show you a little bit more of how they work, and we can like make the dragon actually like execute in its own Go routine.
That would be nice.
But maybe it's too much of fairy
Guys,
tale
leave
stuff.
requests in your leave requests for the future token pull requests to Adelina, or in tweets or in retweets and stuff. Like, wow. Can we mention Form 3 in our retweets?
Oh
like,
yeah, of course.
tell them thank you for
Form3 Tech is our engineering handle. Let me just write it here. And it's just been an absolute pleasure coming here. I was a little bit nervous because it was a lot of live coding. So thanks for bearing with me.
It was amazing. But there might be, well, I think this stories thing actually quite worked quite well. It's
And
like,
I know we promised a Java dragon, but I didn't want to like pick on Java. So
yeah, well, Java we have our own holy wars, so it's not only you who decide if you make things in one line. We do holy wars. Oh, in Spring over constructor versus I think versus separate arguments. Anyway, thank you so much. And guys, you have a link. I'll put it back again, so you can please do retweet and with your kudos and with any questions you have, like how can we make it even better, for example. And
I know that I said it was like absolute beginner kind of, but I think there were a couple parts where I kind of like skimmed over it. So let me know if you have any questions and
yeah,
we
well,
can discuss later. Yeah.
well, however experts we are, at least the style of teaching, and it's a big part of our jobs to teach the ones who join the company or join the language and stuff, and it's not easy. And it's not easy to get people interested. So if we could learn just one thing from today, guys, for me personally, it will be how do you make people that much interested? Because not a single one has left, like really. And today it's the biggest number of people being simultaneously, I think. Maybe it's like we never had that many people in one session, I think.
That's high
Maybe
praise.
once,
Thank you
but
very much.
yes.
Thanks for
Okay.
staying.
I'm stopping the recording, but thank you guys. And yeah, thank you so much.